Hey, good morning, good afternoon, wherever you are in your day. Today we're doing volume 14.4, and the why here is because we're going to be making some approximations in our life. All right. I saw this weekend. I thought it was appropriate and kind of funny. Found that this is, it says down here, found one of those people you hear about in math questions. And I don't know how good the copy is, but, how many watermelons can you get in a shopping cart, and here are the dimensions of the shopping cart kind of thing. Probably doesn't happen every day. However, using some of these concepts to make approximations is something we will do all the time. Okay, maybe you can see it now. Right? We generally don't get like, hey, I'm going to measure this shopping cart, get my calculator out, and do this, or I'm not going to measure this gas tank because I can't get to it and figure out how much gas I need to put in. Or we ran some blowers last weekend, and they have mixed gas, and I'll be honest, when I mix gas and oil for those type of engines, it's not always super exact, right? We do approximations all the time, okay? And I'll err on the side of, maybe having to be a little richer in terms of the fuel to oil mixture to make sure the engine's protected. That might not even be right. I'll probably have somebody straighten me out on that. But again, approximations and being familiar with this concept is the why. Alright, so let's get into it. Use your calculator where appropriate. Find the following. Lateral area of this shape, and we did that. So the lateral area is everything that is not a base. So, ready to the front. Lateral area of the front is 20 by 16. And if there is a front, there's a back. And then I also have to get the lateral area of the side. And that is 8 by 16. And there are two sides. So I just do that math on my calculator. And when I did that, I got 896 centimeters squared. Now it says area of a base, a singular base. Well, the base to me is this down here. And to me that is 20 by 8, which is total area. Lateral area plus the area of the bases, of all the bases. So that's going to be 896, which is the lateral area, plus 160. And there are two of those 160s. And when I do that, I get 1,216 centimeters cubed. Volume, a couple different ways to think about it. This was drilled into my head in school. Volume is length times width times height. Another way to think about it is area of the base times the height. So it's all the same. 20 by 8 by 16. And that is cubed. There are three dimensions of volume. Volume is how much water goes into a fish tank. Volume is how many boxes of Girl Scout cookies you can get into an SUV. Volume is the amount of sand in the sandbox, right? It's three dimensions. Area is 2D. It's just a face. There's no depth component. Okay, so that is that. Down here, there's some word problems. Base is 72, height is 9. What's the volume? You just multiply them together. And remember, volume is cubed. Couple more. Now, volume is area of base times height, or volume is length times width times height. So I just plug in what we know. Volume is 343, 98 is the base, and then h is the height. So you just divide both sides by, and you get, and the height is just linear. It's just up and down. There's no two-dimensional component to height, and there's no three-dimensional component to height. 9, so volume equals base times height. I've got volume. I don't know what the base is. The height is 12. I know how to solve that. I divide by 12. Get 144 meters squared. This is 2D. Good start there. I guess I wanted to do 8 for you, which is very similar to 7. Volume equals base times height. 1952 equals 122. H divided by 122. And H is 16 inches. Let us bump down to 12. The area of the base of a hexagonal prism has area 78. The height is 7. So volume, base times height, base is 78, height is 8.5. Multiply them together and you get 663 centimeters cubed, because it is volume. Three-dimensional. Length times width times height. A cubic foot of ocean water contains 1.5 pounds of salt. Find the weight of the salt in a rectangular container of ocean water measuring 6 by 4 by 2.5. That would be the amount of ocean water in a container measuring this. That would be the volume of that container. We could put that much water in there. So when I do that, I got 60. So that's 60 feet cubed. And then it contains 1.5 pounds of salt. So I'm just going to take the amount of water and multiply it by the amount of salt in the water, and I get 90 pounds of salt. Alright, that is all she wrote for that. I hope that makes sense. I hope that helps you. We will chip away at this, we'll chip away at the other, we'll keep getting ready for the tests where we cover surface area, volume, and all that good stuff. Thank you for your attention. Please have a great rest of your day.